Okay, if not, then let me start trying to share with you so I'm going to share. I'm trying to see where's my browser here. There was some sort of a video that I thought I would share with you that's talking about desalination. There are things that we are trying, checking the net as well as we are moving forward. Not sure that we can get that. If not, then what I can do, I can just save it as an MP4 file and then try to run it next time, inshallah. Yes, it seems that it's not responsive. So what I may do, I'm going to share my presentation with you then. Are you able to see this screen that I'm sharing?
Yeah.
Yes.
So here we are talking about thermal desalination systems as an introduction to the subject of the course. This is an interesting thing to know that there is a large quantity of water, huge quantity of water in the earth. However, 97.5% of water in the earth is water that we cannot drink. It is basically water which is stored in, or you can find it in oceans and seas. So it's salty water, it has high content of salt, so it's not suitable for drinking. The fresh water is only 2.5% all over the world. And it is not all of it available for us. There is a part of it on the glaciers, snow covers, Jibal al-Jalid, that has most of it, or in swamps, mustanqaat, fresh groundwater, water underground in the wells, المياه الآبار اللي احنا ممكن نشربها. And this is making the most of it. When you look at the quantity which is available for us for drinking, you will find it is about 29% of the 2.5%. So at the end, we have something that's about 1% of the water available throughout the earth is suitable for drinking. And it is basically located in rivers and springs. The problem is that it is not enough for the current population of the earth. That's number one. And number two, it's not evenly distributed. So it's not, you cannot find a river of sweet water or springs of sweet water in every country in the world. There are countries that are suffering from the lack of water, sweet water, and the Kingdom of Saudi Arabia is not an exception. We are facing this kind of problem, that there are no rivers, the underground water which is suitable for drinking is not much, and accordingly it's not enough not only for drinking but for the industry. You don't need only water to drink, but you need it for all the industries, and we need it also for agriculture. If we don't have enough water, then most of the country is going to be in the form of desert, which is the case basically in the Mediterranean, north of Africa, and the Middle East, which is basically called the MENA region, Middle East and North Africa. So there is water, but this water is not suitable for drinking. This water probably was suitable for drinking, was enough in the year 1923. But you can see here how the population is increasing. We are talking about, we have exceeded 7 billion persons throughout the world right now. By 2050, it's expected to be something which is approaching 9 billion. Quantity of the water is the same. It is conserved, but the consumers, the people who are using the water, that are increasing. You can see here some sort of almost a linear increase of the population. That's again another way of showing what I said, another way to present what I said a while ago, that we have water on the earth, 97% of it is saline water. The fresh water, we have about 70% of it in the form of ice and 30% in the form of groundwater. And then surface water is a very little quantity, and then others. Then the surface water in the form of lakes and swamps and rivers are 2%. So when you look at the end, how much sweet water you can find throughout the world, it's something which is 1% or less from the available water. And this is a challenge. And engineers are the ones who are facing this kind of challenge of how to make this water suitable for drinking. And doing it, it's not only enough to just convert it into sweet water, but we need to convert it effectively and at a low price. This is a map of the world, which is showing areas of waters that are suffering from shortage, places in the world suffering from shortage of water. And look at the red color in the map. You'll find that this is in the north of Africa, the Arabian region, and part of the Middle East region, Arab countries, Gulf countries, and part of Asia as well. That also applies for, maybe it's not shown here, but the west of the United States of America, California, for example, is facing a problem related to drought and access to sweet water. In our next slide, again, we're going to have another map which is showing the large desalination plants around the world. You can see most of them are located where? Answers?
In the Middle
Gulf
East.
country and Arabic country.
Exactly. It's basically look at the north of Africa and look at the very high concentration of desalination plants that are located here in the Gulf area. You can see clearly that there's a tremendous quantities of plants that are in the east side and the west side of peninsula. I'm talking about the eastern region and Gulf countries. And on the other hand, the other side, which is the western coast of the kingdom. Some are in India, some are in Australia. And these are the places that are suffering basically. You can look at North America. There is a big red dot close to California. And look at South America as well. There is in the north and at the west side. So there are many places in the world that are facing this kind of problem, and an action needs to be taken for making making sweet water available as much as possible. And this figure here is telling us where do we stand. Look at the bar that represents Saudi Arabia. We are talking about something which is in the order of about 20% of the whole world desalination is being produced only in this country. And the major entity which is responsible for producing water is SWCC, Saline Water Conversion Corporation. Its headquarters is in Riyadh, and its biggest, I can say, administration is located here in the Eastern Province in Jubail. They have a research institute, which is basically focusing on sweet water. It's taken it from different aspects. One of them is monitoring the plants that are producing water, having chemical tests for the quality of the water, for the marine environment, because desalinating water is not only a matter of energy and quality and quantity of water which is being produced. But if you are taking seawater, you are evaporating part of it and condensing it, then the part that will not condense is going to be higher in salinity. The salt content is going to be higher, and you are going to send this salt again to the sea or to the Gulf. So how does it affect the marine life? The fish and other creatures that are living there, how they're going to be affected by that, and that's something which is being shown here. And that's something that will be discussed, and it's taken care of in SWCC.
Victor?
And they have, yes, go ahead.
I mean, the desalination won't affect the level of the water?
Not the level, because what we are taking for desalination does not represent a percentage of the whole water in the globe. The quantity of water in the oceans is so large that whatever you took is so small of that. So actually really resulting in decreasing the sea level. Actually, if you are following the news lately, we are facing the problem of a little bit of 1 centimeter or a few millimeters increase in the sea level because of, anybody knows?
Yeah, the melting of
exactly, melting
glacier.
of the glaciers. That's something which is making this kind of problem here. That yes, we have a problem of increasing the level of water, and this is due to global warming. So that people started to say that now after 50 years, how the cities on the seashores are going to be affected or so.
So we helping them, I mean, by desalination. I mean, because we taking the water. I mean, is there any graph or something that shows how much desalinated water is compared with the total water in the earth?
Yes, that's a very good question. Actually, I was having this in the video that I was planning to show today. There is an issue here that it did not run. Maybe it was not running through the net. So I'm going to do a couple of things. I'll share the link with you. And if I'm able to convert it into an MP4 file and share it with you next time, you will see that it's talking about the quantity of water in the oceans, which is in terms of billions of gallons. And what we are taking as desalinated water is not really a big deal. So it's not affecting that. I mean, we are looking at it as a heat sink or a mass sink, that whatever you take out of it, it's not affected. Okay. So, I mean, you don't worry about the issue of the level here because it's not really, the desalinated water is a very small quantity. Another thing, when you look at this graph here, you'll find that Saudi Arabia and United Arab Emirates are producing a quarter of the whole world desalinated water. And yet there are expansions and there are more and more desalination plants to be built. And probably you heard about some projects here that they are trying to use the solar energy through PV systems, photovoltaic systems, to run RO units. And an example here is in Khafji, and in Emirates as well, there are some plants that are being built using this kind of technology. But I mean, when you look at that, you'll find that Saudi Arabia, United Arab Emirates, Kuwait, Oman, Iran, United States, definitely Japan. These are the countries that are producing more and more. Spain is another example. Libya on the north of Africa, Italy, south of Europe. So these are the countries that are producing more and more and more of desalinated water. And that's obvious because of the lack of natural water resources over there. This is another, I just added this figure yesterday. I was reading an article and I found that this might be interesting for you to see. It's talking about a couple of things. One of them is the increase in desalination plants and the quantity of water that is being produced over the years. You see, where did it start? Industrial desalination here, it shows that it's close to 1960. Actually, the first large-scale desalination plant was built in Kuwait by American company Westinghouse. That was in 1957. It was an MSF plant. Interestingly, the plant used to operate for 2 weeks and they shut it down for maintenance for 4 weeks. And then 2 weeks of operation and 4 weeks of maintenance. Why is that? Because basically, the salt is aggressive to the material. So corrosion can occur very quickly. So they had to, and there was the industry in terms of surface protection was not very advanced then. That's why they faced a lot of problems in terms of corrosion by the seawater then. And then the technology has improved a lot. You can see here the increase in the desalination plants in terms of number. And the quantity of water is showing an exponential increase up to 2020. We are talking about here, the dashed line is the desalination capacity. And we are talking about the desalination capacity that has exceeded 100 million cubic meter per day. This is the world production as of this moment now. The desalination plants that are located throughout the world are close to 20,000, with about 16,000 of them are up and running, and the rest are being commissioned, which means that they are being built and have not yet started to operate. Or some of them are aging and they need to be replaced. The lifetime of desalination plant is normally about 25 years. The good news is we have desalination plants in the kingdom that has lived for more than 38 years. And they are still operating with the same specification they started. And that would give a message of how good the maintenance and the experience of people here have been accumulated throughout the years. So people here, engineers and technicians, are able to maintain specifically the MSF plants that are lived all that period, close to 40 years, and they are very good in operation. They started to replace some of them lately, not because they are not operating, but because they are consuming more energy and the new plants are consuming less energy. So that's the only reason. So the plants are being aging, and they found that economically they can make a replacement for some of these aging plants. The small
Victor,
that you have here, which is...
what's the difference between the blue and the green one?
Yeah, the blue ones are the total number. The green ones are the ones that are operating, producing water.
Okay.
So some of them are being built and have not yet started to produce, or some of them are aging and they are in the form of replacement.
Clear.
Okay.
Yes.
The other figure inside is talking about the technologies. Probably you will not be able to distinguish between all the technologies right now, but you can see here that the black line is the total, the blue line is the RO, reverse osmosis. And this is an interesting story because reverse osmosis started in 1980s. It was very weak, and then there's a lot of investment that has been done into this area. A lot of companies are investing to produce the membranes of the RO, and that's why all over the world it is picking up now. It is basically taking share of maybe 2/3 of the water desalination in the world is RO, but not in the kingdom and the area here. Still here, we are relying more on thermal systems because we started the desalination systems more than 40 years ago. And by that time, only desalination systems were thermal, basically MSF. And that's why you'll find that most of the high productivity of thermal desalination systems are located here in the area. Lately, last year, there was a decision to go more into the RO technology, which means that the plants that are going to be built in future are going to be basically RO, and some of them are going to be, if you see that orange line talking about MED, because this is a comparable in terms of energy production to the RO, it is more stable in operation. So still it is considered, but it needs steam, which means that for these plants to be there, you need to have a power plant and you have steam from the boiler and you can use it for generating the water. I have a photograph here of the Ras Al Khair desalination plant. Actually, what you see here is one element of the unit. This element alone is producing 91,000 tons per day. It is the largest of the world, and it is one of 8 units that are located in Ras Al Khair. The weight, actually this one has been assembled and it was brought on a ship So it was not assembled here in Ras Al Khair. It was assembled in the company that has produced it, and they brought it here into special trucks that were designed and manufactured to carry this unit. It is 4,150 tons in weight. So it is the largest ever. It is coming on a mega ship that has brought it here to to Ras Al Khair, and then special tools, special trucks have taken it, carried it to put it in place in Ras Al Khair. It's operating now. I took this one from one of the world authority in desalination and one of the big consultants in worldwide desalination systems. His name is Leon Orbach. He's the one I'm putting his name down there, and he is a dean of what they call the IDA, International Desalination Association Desalination Academy. Again, this kind of percentage changes like the stock market. You can find that it's been increasing and decreasing based on the quantity of water which is being produced every year. I think now we have exceeded 19% of the world desalination production. Here it is written 17, but that was 2015, and this keeps on changing every now and then. This figure talks about the Middle East, which is producing 53% of the whole world desalination. Obviously, the Middle East is having basically desert nature, and that's why we're having this kind of big quantities of water desalination, followed by North America, 17%, Europe 10%, Asia 10%, and then Africa 6%, and so on. Here in the Middle East, Saudi Arabia has taken the lion's share. The biggest producer throughout the world basically is here. You see the previous figure was 17%, this figure is 18%, and that's what I'm saying, it varies from year to year depending on the productivity that you have. So 18% and UAE 16%, we are talking about 1/3 of the whole water desalination throughout the world is being produced in these two countries, Saudi Arabia and Emirates, with different shares for different countries, as you can see it here. This is another kind of statistics, which is talking about how many of, or what's the percentage of the plants that are in operation, how many pumping stations that we have, how many pipelines that we have. This is all in Saudi Arabia. So believe it or not, that we have 4,500 kilometers of pipes that are spreading and distributing the water. I'll give you an example. The desalination plant, which is located in Jubail, is feeding Riyadh. So basically it is having the largest quantity or a tremendous quantity of water desalination. And this water, the desalinated water or the sweet water, is pumped through pipes going from here to Riyadh, with pump stations every about 100 kilometers, so that you can increase the pump and avoid the cavitation problem. You can increase the pressure and keep the water reaching Riyadh. In Riyadh, there are some sort of large 3 aquifers. The word aquifer, it means a very large tank located under the ground, where it is a strategic storage of water that's enough for Riyadh to live on this water for about 3 days. So in case of emergency in the pipeline, there is enough water for the city to have. And actually similar pipelines are being extended either from the Eastern province or from the Western province to different cities. For example, if you have water in Qasim, then it's coming from Yamba. If you have water in Mecca and Jeddah, so this is coming from the plants in Jeddah and so on. And there are other distributed desalination plants on the Red Sea, which are feeding the cities that are residing over there. Now that we have seen this image of water desalination throughout the world, now I think we are in a position to address these questions. Why, where, and what is the need? At this moment, I'm going to stop the presentation, And then let's turn into some sort of a discussion. So first, if we're asking the question, why?
You mean why do we need it?
Why do we need desalination?
We need it to drink water, of course. There is a high consumption of water and there is no natural sources, so we have to do it.
Fine. So this is the first thing that we take from today's discussion, that there is an increase in the population. And remember, it's not only the population, but it's the population and the needs of the industry. For example, you have taken thermal power plants, you have taken in Thermo 2, or even in Thermo 1, and there's something called feed water heaters. There is a condenser, there is a boiler. Through the condenser, the boiler, and the feed water heaters, we should have very high quality, even better than the quality that we drink. To water, it has to have some minerals. If you brought any water bottle, I'm just turning the video again. Look at this water bottle here, which is, you can get it from the market. And when you look at the water bottle here, you'll find that the contents, which is basically, I know I'm not sure if I'm able to show it here to the camera, but here it has something that tells how much is the contents of salts in. We need salt, we need minerals for our body. So you cannot drink 100% pure water. It's going to affect badly on our digestion system. So have some water, some kind of salts, calcium, magnesium, sodium, potassium, iron, bicarbonate, chlorides. So these are all needed for our bodies. And that's why when you look at it, we have an expression that we call TDS, which is the total dissolved solids. These are basically the minerals or the salts that are available here. And this water for me, which is called, I don't want to make a commercial, but this water is about 155 parts per million of salts. And this is a typical value. Some other companies, you will find that they have 120 ppms and so on. So it's a range. And this range is the range of water which is needed for us to be able to drink safely and which is useful to our bodies. But if you are boiling water and condensing it, when you start to drink it, it will not taste well because it has no salts, and these salts are needed. So that's something that that's important. The water which is needed for the desalination plants, for the power plants, like in boiler or a feed water heater, should have a ppm that does not exceed a value of 5, which means that it has to be almost distilled water. So the water needed, and the water needed for the pharmaceutical industry, صناعات الدوائية, to produce medicines, it should be very pure water with no salts at all. So that's...
And also the farms, I mean, consuming maybe the largest, or if you
the
have...
largest normally for drinking, and then it depends on what kind of industry that you have. Khalid, you had a question. Go ahead, please.
Yes, good morning to you all. Doctor, but what I understand is that you mean the drinking water that we consume, it does have some ratio of salt.
Yeah,
but
that's
we don't taste it. I mean, is it? I mean, why we don't taste it?
You will not taste it to be salty. But to answer your question, I would ask you to do something after the class finishes. Go and boil some water.
All right.
On the top of water, put a surface, maybe a dish or so. And then you'll find that then some condensate is going to form there. Taste it. You will not like the taste. This is pure water with no salts at all. Compare this with the water that we drink and you'll see the difference. So you don't feel the water is salty, yes, but it has minerals. And as I mentioned, what is the quantity? It is about 120 to 150 ppm. ppm parts per million. So you are talking about a volume which is 0.001% or so. So you will not feel the taste of the salt, but it is having some salts in. Did I answer your question, Khalid?
Yeah. Thank you so much, Doctor.
Okay, try this as I'm telling you, and tell us next time what you have seen.
I will.
Yeah, but normally it's not recommended that we rely on this water for drinking. I do remember a case, قصة كانت حصلت. We were in like a gathering or meeting in Al Meridian, which is something called Water Arabia that's been done every 2 years. And there's somebody was there coming to market his production. He has a company in the United States of America. And what he's doing is that he is condensing the water vapor in the air and converting it into sweet water. You can see that if you have any air conditioning system, you can find that there's some water falling. That's something that you can even see لما بتمشي على الرصيف في الشارع ولا شيء. تلاقي مثلا المحلات اللي حاطه المكيفات في تيوب طالعه والتيوب دي نازل منها ميه. This water is being condensed from the air. You have a cold surface in the evaporator of the air conditioning. And whenever it's humid, you'll find that water vapor is going to condense and fall down. This man made a company, which is basically having a small cooling system, and the evaporator having the freon passing inside, and outside he's passing air from the surroundings. And this air is condensing out its water vapor, but the water vapor is pure. So he was saying, well, people will say it does not taste well. It tastes nice. And if you are having a problem talking about that there is a loss of minerals, then what you can do is drink a couple of cups of water and take a sandwich of hamburger. Then it will take care of the minerals which are needed for your body.
Right.
So the point here is, it's probably partially true that you can get some water which has less salt, and you get your salt from the food. But definitely you cannot rely on water alone without any salt. It will not taste nice, and that's something that probably, that's why many of these desalination plants, they have something called post-processing or post-treatment. After you bring the water, you measure the salinity, you measure how much is the salt in it. If you found that it is less than what's needed, they pass it by sort of natural rocks that are having salt, and it does a compensation. It adds salt to the water so that we can drink it. So that most of the desalination plants that are relying on thermal desalination systems that relies on evaporation and condensation, you know, evaporation, vapor is pure. When you condense it, then you have pure water. Then they add some salt to it before we drink it. And that's what they call post-treatment. So far, the ones that are contributing with me are Hani and Khalid. So I need the others to join the discussion with us. We put the first question of why desalination. The second is how. Shall we get another volunteer, or should I call the names myself?
What do you mean by how, doctor?
How do we produce sweet water? We talked about that already.
As you said, there are a couple of procedures when we're explaining in the syllabus. There was the evaporation one, and there was the MD, if I'm not mistaken.
Actually, yeah, that's right, Sultan. That's correct. So the point here, as Sultan has mentioned, that there are different techniques that are used for desalinating the water. Part of it is evaporation and condensation, which basically you're trying to mimic or imitate the natural water cycle that you have studied in physics in the high school. That the sun increases the temperature of the water, evaporation will occur, the vapor will rise up. It will make clouds. Clouds will be driven by the wind, where when it goes to a cold place, they just condense and fall down as rain. Then the thermal desalination systems, what we are going to talk about through the semester, is basically around this. We heat the water, and that's why energy is needed. This water is going to evaporate, you take the vapor, you condense it, and then you have sweet water. So this, in one sentence, it's talking about what we are going to do throughout the whole, but we're going to talk about it in different techniques. The other one Sultan and others, that there is something that we call the RO systems, in which we are producing water not by heating, but by applying pressure. And I'll be sharing with you a file or some figure that shows how this is being done. So how? We have different ways. One of them is by evaporation condensation, one by applying pressure, one by ionization. Salt is an ion. So these ions can be separated from the water by electric charge. So another way of doing desalination can be done by what we call electrodialysis, or ED, in which we are separating the salt from the water by ionization, and then you have the water separated. This is an evolving kind of technique. It has not yet been commercialized, but this is one idea which is there to desalinate the water.
Doctor, I have a question.
Yes, go ahead, please.
Which method or which process is the most
sorry, but this is Ahmed Al Hussein, so that others know who is talking.
Yes, I'm Ahmed Al Hussein. So which process is the most efficient, RO or thermal or the ionization?
Actually, so far there is a competition between two of these processes. One of them is the RO, and the other is one of the thermal techniques called multi-effect desalination. Both of these are consuming the lowest energy needed for desalination. And then it depends on the location. Because the RO is successful whenever you are talking about a low salinity water. But if you are talking about a high salinity like the Gulf region or the Red Sea, then its consumption becomes very much comparable, sometimes more than the MED. So now it depends on the quality of water that tells. The thermal systems are independent of the salinity, because what you are doing basically is that you are heating and evaporating. So whether you have less salt in the water or more salt in the water, the difference in the evaporation or the boiling point is just fraction, maybe 1 degree or so if it is very salty. So the energy needed for desalinating the water is not dependent on the salinity. But for the RO systems, it is a strong function of the salinity. The more saline water, the more energy which is needed. For example, in the Mediterranean, you may spend 2.5 kilowatt hour to produce 1 cubic meter of water. This value, if you are talking about good quality of water in the Gulf region, it can be 4.5, not 2.5. And in some cases, due to some low qualities of the water, I'm talking about the kind of planktons, العوالق البحرية, and so on, it can even increase to something between 6 to 8 kilowatt hours per cubic meter. So this is all RO, but it depends on what's the quality of water and how you are going to, or how much energy you need to desalinate this water.
Doctor?
تفضل.
Have you heard of graphite structure filtration of water?
Yes,
it happened recently.
Yes, actually, we have done some work with that maybe a couple of years ago, where basically what we did is, I was going to talk about a little bit later in the course, but since you asked the question, what we used to do is produce membranes, which is like the ultra filtration membrane. And we did experiments here in the lab so that we can cover the membrane with graphene oxide, layer or layers of graphene oxide. The reason of doing that was not really to remove the salt totally from the water, but what we wanted to do is to remove the ions that are resulting in hard scale and soft scale. I'm talking about carbon الحجر الجيري اللي هو الكالسيوم sulfates and calcium carbonates, magnesium oxides. These are all kind of problems that result in scaling and fouling in the desalination plant surfaces, whether it is RO or thermal. So what we did and what the effort has been done naturally is that using nanotechnology. Graphene oxide is one of these applications, which is a very, very thin layer that you can use it for covering the surface of the membranes, or basically this is done for pre-treatment. So what you do, you don't make this fouling or foulants stick to the surface. This is number one. And number two, it is made in a way so that the distances between the layers do not allow for the calcium sulfate, calcium carbonate, magnesium oxides, ions to pass through them. So this is existing. That's something that we have done. We have patented also. And there is another patent that has been done by applying the nanotechnology. And this has been done in SWCC. They have a combination between pre-treatment with nanofiltration before introducing the units to either thermal or RO systems of desalination. Did I answer your question?
Yeah, thank you.
Okay.
Doctor, what do you mean by scaling? What is it, scaling?
Scaling